So this will give us a good chance to practice some of those skills, especially with your calculators. I want you guys to start here. In my meeting yesterday, I noticed the number of people paying attention to the training was declining throughout the day. We were all on Zoom, so I couldn't really tell. Here's the data that I collected for hours 0 through 6, so beginning of the conference all the way through hour 6. Number of people paying attention. I want you guys to use your calculators, make a scatter plot, sketch it, and I also want you to find the equation for the least squares regression line and find R.
It is your window, so hit shift and window. Yeah, okay, so right now what it's showing you on the x-axis is going from negative 480 to a little bit over 4,000. I'm guessing that it's not showing up just because your window is so large, these dots are so tiny. So I'm going to change this to negative 10 for x and positive 10. That should be plenty large enough to fit that information in there. Okay. And then for your y-axis, let's go from like 0 to 100. So 0 and then 100 there. See what happens if you graph it now. Okay, yeah, you're welcome. Okay. Did it give you an error or it's just not showing up?
It's not showing.
Okay, so let's go into your stat plot. It's turned off.
I think from when we reset it.
Yeah. So if you hit enter there, and you click enter again, now that's highlighted. And now if you hit zoom 9, it should show you your scatter plot. There you go. You're welcome.
I keep getting this when I try to do the Zoom thing.
Okay.
I check the lists and they're like,
And they're
there's
matched?
No, yeah. there's
Okay.
no missing.
So it says there's a syntax error, so I'm going to hit go to see what it's actually fussing about. Okay. Somehow there's an equation loaded into your y-axis, or your y equals menu, so we're going to clear that out.
Okay.
Let's see what happens now. There you go. You're welcome. Yes, ma'am.
Every time I go to the pad, it keeps saying error.
Okay, so a syntax error. So arrow down. We're going to go to. All right, let's clear all these equations out. Because it's trying to graph all of those and your scatter plot at the same time. All right, so now hit zoom 9 and see what happens. There you go.
Thank you.
You're welcome. Yeah, if it gives a dimension mismatch error, that's something in your X list and your Y list that aren't matching up. If it has a syntax error, usually there's an equation that's been stuck in your Y equals menu. All right. Yes, ma'am.
What do I do after this?
9. We're going to zoom it in.
Option number 9. There you go. All right. All right, I've got my scatter plot up on the screen, my equation, and R value. Go ahead and check yours against mine, see if you guys got the same thing. How would you describe the data based on the scatter plot? Oh, yes, absolutely.
I don't know if I did it wrong, but I got like a lot.
All right, so show me your output here.
Where did I go?
Do stat, go over to calc, and we're going to go down to, I think it's option 8.
Okay, I think I did 4 then, because I think if I did 4. Oh, maybe I just put some negative. Okay.
Okay. How would you guys describe this? Yes, sir.
I said it displays a very linear relationship between hours passed and the number of people paying attention. And as time passes, the number of people paying attention decreases.
Love it. So you've got direction with the decreases. Whenever we are describing our data from a scatter plot, we have that acronym. Do you guys remember its 4-letter acronym to help us remember everything that needs to be hit? DUFS. SOX is for my 1 variable data. This is 2 variable data because I have stuff on the x-axis and stuff on the y-axis. 2 variable data, we've got DUFs. You want to describe direction. Mohammed, you absolutely describe direction as this thing goes up, this other thing goes down. Or you could say it has a negative relationship. That's another way of explaining direction. What's the U stand for? Unusual features. Do you guys notice any unusual features here? No. But you would want to make sure to state that. There were no unusual features observed. What was the F for? Form. You said it has a linear relationship. That is our form. So you hit that one as well. And what was the S for? Strength. That was the only thing that I don't think I heard in yours. You did say that it has a linear relationship, but technically I can draw a line of best fit through anything. It doesn't mean that it's the best model, but I can draw a line through anything. I can grab a straight edge.
What if I said a very strong linear?
Yes, I would say that it appears to have a strong or a fairly strong linear relationship. Having this R value here is going to lend a lot of weight to calling it strong or weak or moderate. I would say a negative 0.99 is just about as strong as you can get on a linear relationship. The only thing that would be stronger is a negative 1. That would be a perfect linear relationship there. All right, so we have a strong negative linear relationship between time and number of people paying attention. There are no outliers or unusual features. Sorry, I forgot to mention, Mohammed, you did a great job of including context in your description there. Always make sure that you're including context. Let me pop that up a little bit higher on the screen. Strong negative linear relationship between time and number of people paying attention. No outliers or unusual features. If you didn't use my exact words, but you hit on all those same big ideas, don't change what you wrote. You want to make sure that you're saying that as one goes up, the other goes down, or that it's negative. That means the same thing. You definitely want to comment on the strength of it, and you need to make sure to work in context. All right. What I want you guys to do next, I know we found the line of best fit, we found our regression equation. I want you guys to use these formulas now. These formulas will be given to you on the exam. You don't have to memorize those, but I want to make sure that you know how to use them and how to find these pieces of information on your calculator. So to find Sx and Xy, to find X bar and Y bar, the mean of our X's, the mean of our Y's, you're going to go to Stat and Calc. The second option down there is for 2 variable stats. That's what you want. Make sure that it has the X list as list 1, where you put in your your explanatory data. Make sure your Y list is list 2, which is where you put your response data. And then you click on Calculate. all of these different pieces will be there. You might have to scroll down a little bit to find it all, but it will have a value that's called X bar. I believe that's the very first thing after you hit calculate. SX is going to be a little bit further down, and then it gives all the stats for Y. So that's where you would find Y bar and SY. Remember, SX and SY, these are the standard deviations of our X's and of our Y's. So I want you guys to do that on your calculators, find those values, substitute in, and I want you to make sure that what you get for the equation then matches what we wrote up above. And just as a reminder, y hat equals a plus bx. That is the form of our equation. So once we find a and b, we can plug those values in there. Okay, so there's your x bar. You're going to use that in the y-intercept formula. Right here is your sx, 2.16 something. If you keep scrolling down, there's your y bar. Scroll down a little more. There's your sy. So those are all the pieces that you need to substitute in so that you can find a and b. All right? If you're not sure how to find the values that I'm asking you to substitute in, please raise your hand. I'm more than happy to help you. Yes, there's your x bar, there's your sx, yep. Keep scrolling down, there's your y bar, and there's your sy. Yep. Doing okay?
I think this is
Yes, absolutely, yep. And so it gives a whole bunch of output there. We just need to pick out those 4 pieces. Sorry, Donnell, I just now saw your hand up, dear.
Did this first one right?
0.99. Yep, and then you just plug it into your calculator to find the actual b value. Don't forget that's a negative. Because remember, we had a negative relationship here.
He's kind of hiding your equal sign there.
Okay.
But then yes, that's absolutely correct. You're welcome. So after you find the values from the calculator, make sure you plug them into those formulas so that you can actually find A and you can find B. This is another way to find your regression equation. There are times on the AP exam where they give you raw data, like I did up at the top here, and you have to find your regression equation. There are other times that they will give you statistical output that would include things like R, SX, XY, Y bar, X bar, and they would still ask you to find the regression equation. So I want to make sure that we know multiple different ways to get to any information that they might ask you to find. I got a lot of really useful, helpful information yesterday. The 2 presenters that I was able to see are the 2 authors of the textbook. So that was pretty cool. Yes, ma'am.
I can't find the one.
What happens when you scroll down? There's your y bar. And you
Oh,
scroll.
that's different. Oh, I
Yeah.
thought that was in.
Yeah, it looks like it's a fraction, but no, they're telling you n is 7, so you had 7 pieces of data here. And then your y bar is that 51.57 number.
Okay, thank you.
You're welcome. I'm going to put my work for this up here in about a minute and a half so you guys can check yours against mine. But I know there's still some people working on this. So you need to find A, you need to find B, confirm that it matches with the line of best fit that we found earlier. If you're already done with number 3, then come down and do numbers 4 and 5. See if I can find that one. Jesus. Oh, I thought I had more pictures of that. All right, I'm going to go ahead and put my work up so you can see my values for A and B using this way of calculating. So I got negative 9.393 when I rounded it to 3 decimal places, which, while not an absolutely exact perfect match for the calculator output, is reasonably close, especially when you're rounding. Since I rounded my SY to 3 decimal places, that's why I rounded the output to 3 decimal places. And if I had rounded SY to 2 decimal places, then I would round my output to 2 decimal places. Similar to science, when you guys do significant figures.
Teachers, pardon the interruption. At this time, please remind your students of their college visit, career speaker, or presentations. Seniors are to the gym. Juniors are to the auditorium. 9th and 10th graders, please begin to make sure you give them their tickets so they know where to go. There are bells for these periods. Please make sure you dismiss at the bell. Thank you.
All right, technically we still have 8 minutes till they're letting us out of here. So I at least want to finish up these last couple questions on this page. If you're a junior, you're going to PPAC when the bell rings. If you're a senior, you're going to report to the 2 main gyms, East and West Gym. I think I only have one person in here that's going another place, and I have already communicated with them. So everybody else should be covered by either PPAC for juniors or gym for seniors. All right. Make sure that when you are doing your line of best fit, your least squares regression equation, you either use your x variable, your y variable, the names for those in your regression equation, or off to the side you have defined your variables. X equals this, y equals this, and include your context that way. So if you want to have y hat and you want to use x in the equation, that is okay, but you still need to explain contextually what those are meaning. How do we find our prediction for the number of people paying attention at 2.5 hours in? Yep, substitute 2.5 in for x. What do we get when we do that? Does anybody have that? 56.27. Since we're talking about people, this has to be rounded to the whole number. We're not going to have 0.26 of a person. So 56 people. We found our R value up above. What is that R value telling us?
The relationship between hours and people paying attention is very strong.
very strong and negative. And when we say very strong, it's a very strong what type of relationship? Linear. R is always telling us about the strength of the linear relationship. So from just R alone, I can get almost all of the duffs. The only thing that I can't get from the R value is any unusual features. That's the only thing that I can't tell from just that number. I get strength, I get direction, and it's telling me how close of a match it is for a linear relationship here. All right. I want you guys to do 5, 6, 7, and then that'll wrap us up for today. Tomorrow, beginning a class after we've had a chance to refine our models, we'll do the back side of this. But I want you guys to identify R squared. This is on that same output menu where you got your least squares regression equation and where you got your R value. So stat calc, I believe it's option 8 at that point. When it tells you R, it also tells you R squared. How would we interpret R squared? Yes, ma'am.
97%. It's 0.97. It's a 97% variability in the number of people paying attention.
Yes. Yes, yes, yes. I got 98 when I did mine. So 98% of the variation in the number of people paying attention can be accounted for by the relationship with time, represented by the least squares regression line. If you didn't have this piece in there, but you just had by the LSRL at the end, you want to tag on where x equals time. We want to make sure that we're referring to what this relationship is. So we're talking about the variation in our y. This is in relationship to our x, so we need to make sure to include context for both x and y. But that least squares regression line is representing this relationship, and 98% of the variation can be explained by our least squares regression line. This is where we're going to end for today. We'll go over the answers for 7 and 8 tomorrow. But one of the breakouts that I attended actually talked specifically about R squared a little bit more and provided a more in-depth understanding. Do you guys remember when I used that graph on the board that was showing us the squares and how we could move that least squares regression line and we could see what's happening to the square of our residuals? So what we're talking about here is if we were just going to use the mean of y for our predictions wouldn't be very accurate. If we had information about the time, our predictions about the number of people paying attention is going to be better. Because the earlier it is, the smaller the time, the more people were paying attention. The further on we'd gone in the day, the less people were paying attention. And so that least squares regression line is the smallest sum of squared residuals. So what it's saying is that basically 98%, like we have reduced the sum of the squares by 98% using the least squares regression line instead of just using the mean of y. That's what we're talking about as far as variation in the number of people paying attention. We are explaining most of the differences that we see in our y values based on what we know about our x values. So any kind of variation that we would see in our information collected about y is because of this direct relationship with time. This is actually a spot where researchers will dig in and try to come up with even better models. If we have an R value like this, 2% of what we're seeing in our Y values is not being accounted for by time. So just to pick your brains for like the last couple seconds, what else do you think could account for people not paying as much attention as time goes on? What'd you say? They leave. What else could possibly account for this? Other than just the time on the clock. What'd you say? Boredom. What else? Maybe people had appointments that they had to go for. Maybe they're having internet issues. Absolutely. There's all these other factors that could be going on. That's what that other 2% is coming from. That would give researchers another avenue to say, we want to come up with an even better model, so we know this explains part of it. We want to figure out what explains the rest. All right, seniors to the gym, freshmen to the Performing Arts Center. I will see you guys tomorrow.